back to my channel. Today let's solve a Leetcode problem number 15, 3-sum. So we are given an array of random numbers. We need to count how many tuples or how many subarrays that are unique. We don't have the duplicate triplets. How many unique subarrays that sum of them equals to the target. So the target here is 0. If we did the first Leetcode problem 2-sum, so this is similar to that one, but we will use two pointers method. Basically, we are going to do like this. First of all, we need to sort the array in increasing order. For example, this array, it is a -1, -1. I'll just list a few ones, but not all of them. 0, 1, and 2. So this is our array. If they are in increasing order, we use two loops. The first loop will first find this pointer, the first one I. And the pointer will be I plus 1. So this is another pointer. We name it L pointer because we will use two pointers, left and right. So here will be the right pointer. So we will check if this number plus this number and the first number, three of them equals to 0. If they are equal to 0, we will put it in our result. Here the result I will use a set because I can reduce the duplicate. Because I can delete all duplicate. And inside s.add, inside it will be a tuple because array cannot be checked in a set for duplicate. We have to transform that into a tuple. So the tuple inside will be -1, -1, and 2. And then we move the left pointer to the left. If they are equal, we will move both of them. The left pointer shifted to one place, and the right pointer also shifted to one place. Because if only we shift one pointer, it doesn't matter because we've already find these tuples, so the right pointer should also move to one place. And after that, these three numbers, because the sum of them is also equal to 0, as you can see, -1, 0, plus 1. So we put another tuple inside. After that, because it is a sum of 0, so the left will shift it to here. Here will be L, and the right will shift it to here. Because when we are checking, we use L minus right. Of course, this is out of loop, so our result will have two tuples like that. Now let's get back to the code and let me code it up, and in that way you may understand it easily. So I want to first of all define a set. I will use S to represent a set. And set will return the result. And for here, I will define a number. I will define a variable n. It is the length of the array nums. First of all, I will sort the nums array in increasing order. Then I'll for the outer loop for I in range n, and here I will use two pointers because from here we can use two pointers to solve the problem. So the L and the right pointer equals to 0 and n minus 1 respectively, and while L less than R, here we have the three sum of them. So the three of them will be sum, and inside will be a array, because this method have to use a array because there are three numbers. So basically inside it is the nums I, nums L, and nums R. After that, we need to check if 3 is less than or more than the target. If 3 is less than 0, if it is smaller, yeah, we need to shift the left. So the L should plus 1. In this case, it might have the right value. Elif, another case is 3 more than 0. So the right pointer will shift from the right to the left. So the right pointer will shift 1 as well. And else, it means 3 equals to 0. So this S set will add a tuple inside. So the tuple will be these 3 numbers. So this way we can avoid any duplicate. And at the same time, L should similarly plus 1 and R should minus 1. Here we can return the result as is a set. So here it seems the out, they didn't say the output is a set or array or something, but if the output, if some languages yeah, strictly asked you to return an array, so you should list as, and inside you can also use list to list, but here we don't need it because it seems the test case doesn't care about the data structure of set or tuple. Let's check it. Expected. It seems we listed more values as expected. Let me check what is the error. Yeah, we put more values as expected. Yeah, but inside it is actually, yeah, normally we should not have this kind of value pairs because we only have 1, 2. It seems that somewhere I make a mistake. Let's find that mistake. And here L, yeah, I make a mistake because L should, as I explained, it should be I plus 1 should be the next one. Otherwise, it is totally wrong. Let's check it. Now I think it seems okay. Let's submit it. At the same time, we can calculate the time complexity as we use the nums sort. So here the time complexity is O(n) log n, but for the total complexity, it is O(n) square because it does matter the O(n) log n because there is a bigger case. If we use a big O to calculate the time complexity, there are 2 loops. In each loop, that is O(n). So for this loop, that is O(n). For this loop, that is O(n). So the time complexity is O(n) square. But as you see, the submissions, it is a little bit too slow. And of course, we can speed up a little bit. Here, we can have a check if I more than 0 and nums I equals nums I minus 1, we can let it continue. We don't need to consider because it will always be in duplicate. Yeah. Now let's submit to check if it improves the speed a little bit or not. Yeah, as you can see, it does. It improved a little bit. And why we need that line of code? Let me give you an example. If we have minus 1, and minus 1 and 2. Yeah, for this array, so these 3 numbers sum up equals to 3. But for another one, it is minus 1, still minus 1. Yeah, it means we counted a lot of duplicates. Actually, we don't need to do that. We just need to check. When it goes to this one, -1 equals to this one, we don't need to count, let it continue. When it goes to this one, yeah, because this is still equal, let it continue. Yeah, so we only count it for one time, don't need to count 3 times. Yeah, that takes time as well. But why we can use this? Because the start from this place included all the sub places, so this is why. So that's basically all my code. Thank you for watching. Bye. See you next time.